right, well, welcome everybody. Thank you for attending tonight. Like Hank said, if we have any questions as I go through, please type them in the chat box, and if I don't see them, one of the other agents can help me answer, or we can ask them at the end of the presentation as well. So today what I'm going to focus on is utilizing a stress lot to maximize pastures, because you really can't talk about a stress lot without also incorporating talking about pastures as well. So we're going to do a lot of both, a little bit of pasture management, a little bit of stress lot management, and then incorporating them together. So let's get started, because what I like to talk about first and foremost whenever I'm giving any presentation is to define a pasture. That's so we're all on the same page of what an idea of a pasture is. Because I know right now in your mind, you could be having all of these beautiful pictures in your mind, as we go through really nice, pretty green grass, big areas of open land, horses grazing, happy, healthy animals, right? So, and that's about right. But really size isn't as much of as much of the determining factor as is a land where grass, and I'm going to use this one little highlighter here, grasses and legumes are grown for the purpose of supplying nutrients to grazing animals. That is more the key with a pasture than anything else. So you need to have these grasses and legumes there for supplying nutrients to grazing animals, okay? So if you have a space which you turn your horses out to, but it has no grass, or it's really not supplying much nutrients to the horses, it's not considered a pasture, okay? So all of our pasture plants contain all the nutrients horses need: carbohydrates, fat, protein, vitamins, minerals, even some water. So everything is there that a horse at maintenance would need. And the fun thing is that horses evolved to graze forage, to graze basically pastures. They'll eat small, frequent meals throughout the day, 12 to 16 hours, sometimes even 18 hours, some more recent data has shown. And they'll consume up to almost, ponies, if you've got a pony out there, can consume about 5% of their body weight in dry matter of forage. Most larger horses, some research has shown up to 3.5 or 3.3%. But you have those not so thrifty horses that might be the hard keepers. They're going to be down around 1.5%. So I love to do easy math. I use my 1,000-pound horse. So a 1,000-pound horse can consume anywhere from 15 to 33 pounds of dry matter per day. Now I keep saying dry matter because pasture does have a lot of water in it. It can have up to 80% water. So that means at any one time your horse can be eating 80 to 100 pounds of grass, and that's with the water included in it. Okay. They also cover distances they travel. So the horses in the picture there, they're walking this 40-acre pasture. In 40 acres, they can probably cover distances of over 20 kilometers. But on average, it's about 20 kilometers per day. Their hindgut is set up so that they can digest very large amounts of forage. But again, it has to be in small meals throughout the day. So before we get into the actual stress lot part of this, I'm going to just wind down and finish up my horse feeding basics with the fact that horses should actually consume about 1.5% of their body weight in forage. So that 1,000-pound animal should be getting at least 15 pounds of forage. Granted, some of them are going to be too thin that way, so they need to actually add some other sort of grain concentrate, which we won't talk about here. But that's the bare minimum. A 1,000-pound animal will require about 2 to 3 acres of pasture if that was its sole source of nutrition. And that's during the grazing season. So you can think, okay, we're kind of winding down with our grazing season. I know we've been in a bit of a drought, at least in central Jersey where I'm at. So our pastures haven't been growing as well as they should be kind of this time of the fall. So right now, it probably would require even more acreage per horse just to meet their full needs if they're only on pasture. And we're going to talk a little bit about this and how we can incorporate stress lots into this regime. However, if you have a horse in late pregnancy, lactation, it's growing, exercising, something like that, it's definitely going to need more than just the pasture nutrients are going to supply. Let's talk a little bit more about what we can do with our pasture situation on our farm, and it really does depend on your farm's goals. Each farm and farm owner must decide on their own whether they want something, a situation like down below. Do they want only stress lots, and that's how many horses they have, and that's what they're going to have to do? Or can they have all these beautiful pastures, or do they have room and do they have the availability for both? So we're going to talk about a lot of grazing scenarios where we can encompass both into your grazing plan. So how do we decide what our goals are? Well, you need to make a couple decisions. What are your finances? And I'm not going to, get into specifics there, but, figure out what you can do. What is the size of your farm? How many usable pasture acres do you have? And how many non-pasture acres do you have? And then your time, because sometimes grazing and doing stress lots and things takes a little bit of time. But even more importantly, the stocking rate. How many horses do you have on your property versus how many acres? And then where are all your existing facilities? Where are your waters, your fences, your barns, your shelters, things like that? And I'm going to give you a little example of how Rutgers set up some of their stress lots and their grazing areas to take into account things that were already there, like waters and shelters. So let's quickly talk about stocking rates before we get too much more into the stress lot idea. So it's very typical in New Jersey, especially, to have 2 to 3 horses per acre. Okay, so that means that's just the opposite of what I mentioned. Horses can use for 100% of their pasture as being, given them the full nutrients they need, right? I said 2 to 3 acres per horse, not 2 to 3 horses per acre. So in this case, it might be better to have a stress lot or somewhere where you can get them off the pasture. So you really need to consider the stocking rates in terms of if the farm is going to have the pasture as a significant source of nutrition. If that is the case, you need to maintain your animal densities on the acreage so that you're maintaining at least 70% vegetative cover. Okay, what is that? Well, we're not going to get into that a whole lot today, but I'm sure any of us today can help you figure out exactly what 70% is. But really, when you look out on your pasture, you should not just see green, you should see green edible forage. Because I know I've been to a lot of farms that while they may look green from a distance, they're pure weeds once you get into them. And the horses aren't grazing them. And people might wonder, well, why? It's beautiful, it's green. Because it's weeds and they're not very edible to the horses. So yes, you can maintain one horse on a half an acre, sure. But if you want 70% vegetative cover, you need to graze it probably less than 3 hours per day. So that's not a whole lot to maintain that 70% vegetative cover. If you have this magical 1-to-1, 1 horse per 1 acre, which seems to be the magic number for a lot of municipalities and people that want 1 horse per acre, then your turnout time might only be to about 3 hours, 3 to 8 hours per day. And that might be typical on some farms. You turn out in the morning, you bring in at night. And then as we increase the amount of acreage per horse, you can increase the amount of turnout time. So what if you don't want to manage this? What if you just want to turn them out and you don't want to bring them in a barn? Well, then you have some options. You can definitely increase this with proper pasture management, but you can also increase this by getting them off the pasture and bringing them into stress lots. So in the end, when we're talking about this, and we're going to talk a little bit more about rotational grazing and how to maximize your pasture along with using your stress lots, but the farm really needs to be flexible. You need to plan ahead and monitor your grass condition. The picture down here is a bunch of farmers walking through a field, looking at their grass. Do they have 70% vegetative cover? Do they have weeds? What does it actually look like? And that's really important. If you have a 40-acre field and you've never seen the back corner of your pasture, I think it's time to change that. And you need to start walking your entire farm, your entire field, and then adjust your plan accordingly. So before we really get into the nitty gritty, I just want to really briefly cover how grass grows. And I know it sounds like watching paint dry, but it's actually really interesting when you think of how each of these individual plants in the pasture actually grow. It makes much more sense in terms of how you're grazing your animals and how to take care of the pastures so that they're actually maximized. So here is a real close-up illustration of a pasture grass. Okay, you see the roots down below the surface. So here's kind of that soil surface. You have the roots down below the surface and the stem with all the leaves above the surface. Well, a lot of people feel that, well, the grass just grows down at the roots, right? So here's its little growing buds or growing points. It's just going to all grow from the roots. But what actually happens is that these growing points, as this stem elongates, they travel further and further and further up the stems. So that if you start removing more and more and more of this foliage, you're actually cutting down, you're eliminating the amount that this pasture grass can grow back. And you're eliminating all of these, the possibilities that you'll have more root growth. So we actually call this the take half, leave half rule. So see, anywhere from 10 to 20 to even 40% removal of that pasture grass. So that's this picture up on the top here. If you remove about 40% of it, you haven't stopped any of the root growth. It can still be very, very productive. You get to 50% and it's still pretty productive. You've only really stopped about 2 to 4% of that root growth. So that's not bad. It's still going to come back. But the minute you reach 60, and here's where we get that 70% mark, you're stopping almost 80% of that root growth when you've grazed. So here we are now, you've grazed 70% of that grass. Look at how much roots you've stopped. And then up even 80, 90%, do you think any of that grass is going to grow back? Absolutely not. And we've done studies at Rutgers that have shown that by overgrazing your pastures, it never grows back after even a year. You need to do some major renovation in order to get it to grow back. So how can we stop this? Well, we need to make sure we try to keep our plants in this fast growth period. So that's the fast growth height. So that's about 3 to maybe 10 inches. Let's try to keep it in there. So how do we do that when we've got horses, right? You are all horse owners. You've watched horses graze, right? What do? Well, they actually rip the grass right out from the roots sometimes, and they graze it all the way down to the ground. If you were to look really close at this pasture in this picture, you can see it's a lot of weeds too, but there's very, very little stubble in this pasture. So we've taken about 80% of the grass here and mowed it right off by letting the horses overgraze this pasture. But I know a lot of people say, well, what was I supposed to do? Where am I supposed to put my horses? I don't want to leave them in the barn. Well, if you don't want to leave them in the barn, then, really a good consideration to have would be a stress lot. What do I mean by stress lot? Well, there's a lot of different definitions for stress lot, or a lot of different terminologies. We throw out stress lot a lot, but I've also heard it called sacrifice area. More common term, dry lot, exercise lot, or exercise paddock, they all basically mean the same thing. So it means that it's an area of land where the grass has been sacrificed or is stressed, and it's not meant for grass growth. Okay? It's not meant for feeding horses. It's more of just a paddock. So can we have that or can we have a pasture? Now look at this picture. Is it a stress lot or is it a pasture? Well, to me, it looks like someone tried to make it a pasture and it ended up being a stress lot. So now it's really kind of in between. And it's probably too big because I see the fence all the way over here. We have no idea where it goes off the slide. And we have no idea if there's only these 3 horses or if there's more. So this is kind of one of those in-between situations. But most stress lots are going to be less than an acre per horse. And, the rules, we don't really have any rules, but we say, yeah, they should be at least 400 square feet per horse, which is pretty small, really, when you think about it. But you need to have enough area for the horses to move around. But if you're going to have a pasture, it should be more than 2 acres per horse. Again, for that, giving the horses 70% vegetative cover so that they can actually have more nutrition. So what are some specifics of having these stress lots? Well, again, they're bare soil or sandy mix, little vegetation. They should be fenced. Here's this minimum of 400 square feet. It's best to have long, narrow runs, because what do horses like to do when they get turned out? Well, they like to run, right? So if you have a tiny little box, they're not going to be able to do much running. They'll probably do more rearing and bucking than anything. But if you give them a long run, they can at least run down to the other end, turn around, and run back. And then we should always avoid slopes, because if you have a stress lot on a slope, you're talking about creating a lot of erosion. So it should be on a fairly level ground. It should be stone free, because if the horses are going to be on just a flat surface, it should be either sand about 2 inches deep or sort of stone dust. I think the number one thing here, which I highlighted in red, is that it should definitely have the manure removed frequently. Because if it doesn't, just think about where is the manure going to go. If it's really flat or it has a concave surface, it's going to create puddles, and the horses are going to be standing in their own manure. Or if it's sloped, it's going to exit into wherever is next to it or down slope, whether it be a stream or another paddock, or God forbid your lawn, something like that. So we need to make sure we divert it from the paddocks if we do have a little bit of a slope. So a good thing to consider is a grass filter strip or even a rain garden. Let me show you some pictures. That's what Rutgers did. We actually have a rain garden by some of our stress lots. So here's one lot here where it's really just weeds in there. There's no vegetation. It's meant to be a stress lot. So what we did is we planted an area, and this was actually the Rutgers Environmental Science Senior Design Team did this for us. They planted an area. It's a little bit of a hollow area with all these really nice plants in there, where they were able to take up the nutrients that run through the paddock. They can actually now take up the nutrients from the manure and take it out of the soil before it goes into any waterway. This is the same picture. It's just a little bit more established. The picture on the top is brand new. The picture on the bottom is a little more established. I also have a picture from someone that we work with frequently in South Jersey. They did the same thing on their farm. Here's their stress lot, and they have a little rain garden as well. So what I want to talk about now is how can we incorporate stress lots into rotational grazing? So yeah, continuous grazing is easy. You can reduce the number of man labor, but it also reduces the amount of yield you'll have in your pastures. Versus rotational grazing may require more management, but you're going to have a little more grass yield. So what the effective steps are to have some good rotational grazing is to really look at that take half, leave half rule. Make sure you allow adequate rest periods and don't regraze until your pastures are at the proper height. So what do I mean by that? Most grasses are going to grow to about 6 to 8 inches, and that's when you want to start grazing them. So then when are you going to remove them? When they're about 3 inches, about 3 to 4 inches. And then you let them grow back to 6 to 8. So actually, Rutgers had 27 months worth of a study where we looked at rotational grazing. And the two pictures on the bottom of my slide were taken on the exact same day in late spring on our fields. The picture on the right, this guy over here, is one of our continuous grazing fields. And I'll show you some pictures, some aerial views of how we designed them. There's 3 horses in this field. They've been in there. They don't leave. They graze it 24/7, 365. And look at how little grass and how much bare ground there is. Yet in this picture over on the left, we've got the exact same day. Our horses are grazing about 6 inches of grass, and it was almost 99% vegetative cover. So what is rotational grazing? What's the key to it? Well, the key to it is to have a good stress lot, to have an area where these horses can hang out when the grass isn't ready to grow. And actually now would be a great time, at least on the farm where my horses are. If they had a stress lot, I would advise them, let's pull the horses off. Hopefully we'll get a little rain and a little bit more regrowth before we're done for the winter. So keep them in the stress lot. We have the food pans there. Here, they're food pans. have the shelter, have the water, all in that one area. So when actually the grass does start to grow back, say, next week we get a lot of rain, we get some nice warm weather, and we start to have a regrowth, you can move these horses into the first section of pasture. And then after they're in this first section of pasture and graze it down to that take half, leave half rule, that 3 inches, let's go ahead and move them into section 2, because that's probably ready to graze now. And then you're going to shut the gate. So I probably needed to have this little animation shut the gate so that they can't be in 2 and they're not going to be in 3 and 4 either, or they can't be in 1. Then once 2 is grazed down to the height, you can move them into 3. When 3 is grazed down, you can move them into 4. So now what happens after they're done in section 4? What if it's November and there's no grass in section 1? What are you going to do? Well, you're moving back into the stress lot. And then over the winter, yeah, they'll probably need to be in the stress lot. And that's what we do at Rutgers, because we want to have nice grass come May 1st for them to grow, for them to graze. But if you leave them out there all winter long, chances are you're not going to have much grass for them to graze by May 1st. It's probably going to take even longer for them to get enough grass to graze. You can do it a couple different ways. Here's just a picture of a barn in the middle and a radial sort of setting with the pastures around the outside. And here's actually the system that we have at Rutgers. We actually have 4 systems. And we did a study looking at the continuous versus the rotational grazing. So we've got 2. So there's a continuous and a continuous over here. And we do have a little shed, little portable shed. There's feeders all along the fence line here. Here's a shed, and here's the feeders. Actually, this pasture down in the lower right is the one that you saw in the picture. Each one of these is about 4 acres, and each one has about 3 horses in it. Granted, there are some times of the year where we can put 4 on it and do just fine. But we have one area with a stress lot over on the right with 1, 2, 3, 4 pastures that we can rotate through, and each one's about an acre. And then we have a stress lot over on the left, but this time, this shed and the water and everything was already here, but we wanted to have them graze all the way out back, so all the way up to section 4. So the way we were able to do that is put a nice laneway here. It's long enough for a tractor, so we were able to get a tractor up this laneway. And then we can open up all the way up into section 4, and they can graze all the way in back, but they still have access to their stress lot, which is where their shed and water are. When we wanted to at any given time, we can close the gates for 1. So we can put a gate here. It's a little rope gate with some electric to it, and now they have access into 1. Or we can, I'm not gonna be able to clear it in time, or we can shut gate 2, and they can go into 2, or we can shut 3, and they can go into 3. So at any given time, they've got access all the way down into their stress lot or at any one of these gates. So again, it really depends on what your situation looks like. There's a way to do rotational grazing anywhere with any amount of field. You don't need to have 4 acres. You can have an acre. We had one area that basically was this big, and we divided it into 2 one time, and then we had 3 sections. So there's ways to do it. So what is your forage growth determined by? Because I know everybody's saying, well, how quickly can I rotate? Well, in the spring, when you've got quick grass growth, yeah, it might be 10, 12 days before you rotate. But like now, when the grass isn't really growing, it might be 2 to 3 days before you have to rotate. So it all kind of depends on a lot of different things, like your soil type, forage species, how is your management, what are the weather conditions, et cetera, et cetera. So there's a lot of different things that go into determining how quickly you're going to rotate. So I just want to wind down by saying, I know this wasn't all about stress lots, but really there's really a lot of good uses for a stress lot, and rotational grazing to me is the obvious one. But you also, if you've got ponies and stuff too that can't be out on grass and you don't want them in a barn, such a good way to get them out, get them moving around more and not in a barn. So stress lots have a lot of really good uses. But overall, it has to be good for your farm. So, walk your property, be observant, and really decide what you want to do. So with that, I'm just going to wrap up and say thank you. These are my girls. They're both at farms that one has a pseudo stress lot and one actually does use stress lots quite a lot. So with that, I will stop sharing my screen and I will turn it over. If you have any questions in the chat, I can answer them, or I can hang out and wait until we're all done.
All right, I'm up next. My name is Bill Vampka. I wanted to talk to you. I'm going to set some of the groundwork, I guess, for what Steve's going to be talking about. Well, I'm going to be talking about pasture fertility overall, and then Steve's going to kind of roll into using manure in the plan. So with that, okay. So whose pasture looks like this? For a lot of people, unfortunately, that's what they look like. But this is what we're really trying to get our pastures to look like. And the question I often ask, is this possible? And the simple answer is yes, but it doesn't happen overnight, and there's a little bit of work that's going to be involved when you're doing this. And what I like to refer to as the pasture triangle, which is when we start talking about our management, where we're going to look at the species, that we pick everything we should, are the site conditions okay, and then management. And Kerry talked about using stress lots for management, using rotational grazing as a form of your management. And also what I'm going to talk about is the fertility end of things and how fertility is part of your management plan. Okay, so here's some questions a lot of people ask, and I do a lot of lectures on pasture management overall. And there's a lot of reasons why your previous stand didn't persist, and if you look at some of the causes, you have overgrazing, you pick the wrong forages. But the one I circled up there is poor fertility. And unfortunately for a lot of people, fertility is probably the last thing on their mind. They really don't manage the fertility of their pastures. So here I wanted to start off with a question here. Should you spread lime every year at the same time of year? I don't know. I'm sure a lot of people are saying true. They lime by the calendar, but the actual answer is no. We actually lime according to our soil test, and just routinely going out there every year putting lime down is not the answer. And here's another one I'd like to put up. I've got 4 different pastures here, and if you look at these pastures, can you tell which one needs 25 pounds per acre potash and which one needs 120 pounds per acre of potash? I look at those, and believe it or not, some people may say that the D actually needs 120 pounds and the A needs the 25 pounds. That may or may not be the case. My point in putting this slide up is that you can't just look at a pasture and tell what the fertility needs are. And with that being said, you just don't want to put blanket applications of fertilizer down. Here's a crop, and if you look at this, on the right we have corn, and right in front the your corn, that didn't get fertilizer. And when you look at that, that's obvious to people. But this is what I want you to start thinking about when you're looking at your pasture. Think of your pasture as a crop also. That the pasture actually has to be fed, needs nutrients in it. So if you're looking at this, is this possible without managing soil fertility? The question is no. You have to know what the pH should be for the grasses to grow. You have to make sure you have enough potassium, you have enough phosphorus for root growth. So if you're going to try to strive for this pasture, you want to make sure that you actually have enough nutrients. And this is an interesting study. It was actually done out of Missouri. And this was, they were looking at the importance of soil pH and fertility. And they did a survey across, I guess it was 46 pastures. 86 or 80% of the pastures that were surveyed were classified as having low or very low soil P levels. Okay, so actually the phosphorus levels were actually low in the pastures. If you also look at 37% of the pastures were classified as having low or very low soil potassium levels, and the average soil pH was 5.8. Probably not too different from a lot of the pastures that we have in New Jersey, where people just don't manage them in terms of fertility. They think of them as a crop. And just like I showed you that corn crop, the one on the right was green, it was growing vigorously. That's because it has the nutrients that it needs. Here's another interesting turn too. In the same survey they did in Missouri, they actually found that proper fertility, again, that 1 unit increase in soil pH, remember that pH was 5.8, they corresponded to 4,100 fewer weeds per acre. And this is something when I teach the weed classes, I always tell everybody that soil fertility or management of your crop in terms of fertility is actually one of the methods you have of weed control. If your crop is vigorous, it can outcompete and outgrow. And if you look here, they looked at parts per million of both phosphorus and potash. By increasing them, they also had fewer weeds per acre. So that's part of your weed control too, would be managing your fertility. I kind of put this here too because Carrie talked about stress lots tonight. We also have to look at the animal density that we have. If we are too overpopulated or overstocked, throwing all the fertilizer there is not going to get the grass that we need. Okay, you actually have to balance your stocking density, your grazing management, and your fertility. So just by putting the fertilizer or the lime down is not going to guarantee that you have fabulous pasture grass. Again, as I said here, road to poor pastures, one of the key reasons is poor for soil fertility, as I actually have highlighted here. But there's a whole host of other things that can go wrong, which can lead to those poor pastures. Okay, so when we put those forage grasses out there, I have this chart shows the different types of grasses, and you can see the different peaks and valleys. Well, that's when the different types of grasses actually have their growth. And to get their maximum growth, again, we're getting into the period of the late summer, where we're in the cool season grasses, where we're starting to get the uptick in production again. The grass actually needs to make sure it has enough fertility to keep it growing. That's why sometimes we'll talk about using split applications. Somebody will put spring applications down, and they might do a later application in the fall. And that's to try to match the growth curves of the different pasture grasses that are there. Okay, so we talked a lot about making sure that you have the fertility you need. And we've already determined that you can't just look at the pasture to determine what the fertility is of the pasture. So how do I get there? Well, it's basically you have to use a soil test. You want to do a soil test and you don't want to guess. And the rule of thumb that we use is every 3 or 4 years we should do a test out there. And we'll be fertilizing annually, probably in the spring before the grazing season starts. We might be putting a little bit of nitrogen there. And in the fall, again, we might put down the potash or the phosphorus that we need after the grazing season to help the grass recuperate and to build up reserves to be able to get through the winter months. Okay, so this is basically what we're talking about for soil management or fertility management for our forages. We're going to analyze the soil test results. We're going to correct whatever deficiencies that are there, what the soil test tells us, and we're going to try to strive to maintain optimum soil fertility. That's how we're going to get the maximum growth possible out of the forage grasses. This is the chart that we use. If you've ever taken a soil test, we'll talk about being below optimum, optimum, or above optimum with the soil test level. And you can look at the yields, how the yields start to plateau once you hit the optimum level. Our whole goal is not to encourage any environmental liabilities with excess nutrients. So we want to keep it at the optimum level. And we also want to make sure we're reaching the peak production we can. So that our whole goal when we're doing soil testing is to keep your nutrient levels within that optimum range. One of the things I always tell a lot of people too is just pH management and putting fertilizer down will probably, or actually just liming, does more to turn around a lot of pastures. If you're managing your grazing already and you have your sacrifice area and you're wondering why I'm not getting the growth, sometimes it's just as simple as maybe a lime application and doing a soil test to correct the deficiencies that are out there. And if you've never seen one before, that's a soil test kit. I know a lot of people are looking for beakers and things like that with them. It's really basically it's an envelope where you put your collected soil, and there's a survey or questionnaire in there we ask you to fill out. That's what a soil test is. You can get those at the county extension offices. There's private labs, but that's really the foundation where your pasture management starts. And I might add, if you're doing a new seeding and you're putting a new pasture area in, the kits cost $20. I have seen plenty of examples where people skip this step They put thousands of dollars in to try to establish a pasture, and it failed only because the pH was too low. So this would be the first step before any renovation or establishment that I would be doing. Okay, here's some of the economics in getting that soil test, and I often throw this one out there. Assume you have 5-acre pasture. The soil test costs $20, and we tell you to sample every 3 years. It's only going to be $1.33 per acre per year. And I always give the example, it's getting hard to find a cup of coffee at a convenience store for this price. So it's a very small investment into ensuring that you have the maximum forage growth that you can. And here's how you collect that sample. This is actually before we started all the renovations and the restoration out there at our facility on campus. And if you notice, we have a lot of weed growth in there. So what we first did is we went out. The first step was to see what we were dealing with, and this is how we did it. You're going to traverse the area. You're going to take some plugs out of it down to about 6-8 inch depth, mix them up, fill that bag up, and then send that to the soil testing lab. So we talked about fertilizing and liming. It's basically up to you. There's simple things as push spreaders. The lower left there, that's a small manure spreader being pulled by an ATV. You can have the cone spreaders go on an ATV, or you can have the full size equipment. And if you're laying out your paddocks or your pastures, make sure that you have adequate width to be able to get some equipment through, because that makes the job a lot easier. So when we get that soil test back, we have what we call essential elements, and I'm not going to go through them, but you can see the N, P, and K that we all talk about in fertilizer. Those are our major nutrients. That's only one part of the nutrients. We talk about calcium and magnesium. That's from our liming program. But you can see there's a whole host of nutrients that are necessary to be able to get maximum growth out of your forage grasses. Okay, so you went out and you took those samples and those plugs, you mailed them off to the lab, and this is what you're going to get back. You can see there's bar charts on here that tell you what the level is, with that below optimum, the optimum. There's a pH reported, and if you can look down, we look at the calcium and the magnesium levels. On the results that you get back from this, most of the pasture tests all run across the county agent's desk. We'll make recommendations specific to your pasture as to when nutrients need to be applied. When we talk about the soil pH, this is one of the things that's very important. In the chart I have here on the right, we often talk about a pH of 6.5. That's high even to 7 for grass. The reason we do that is if you look at these bands where the individual nutrients are, we want those bands to be there at their widest, and that's the pH where most all the nutrients fall into being available. You don't want it to slide off being too narrow like they are to the left on certain nutrients, but when you get into like the boron, it actually becomes a little bit more available there. But this is the whole reason that we're trying to lime to that 6 to 7 range to have the maximum availability of nutrients. And that's why it's troublesome when we start to get these pHs that are like 5.8, 5.5, where no lime has been applied. The availability of the nutrients to get your maximum growth is not there. A little bit of a shout out. This is one of our extension publications put out by Joe Heckman. It's Nutrient Management for Horse Pastures. It's Bulletin 312. If you're not aware of that one, if you're keeping horses, that's where you can go for information on managing the nutrients within your pasture. And another one we have is soil fertility recommendations for pastures. This is another new fact sheet that came out. Those are good resources, and that after you get that report back, you can refer to this to see what type of nutrients we're talking about and what their role is in your pasture plan. And just as I put this here, just to show you, this is actually a ryegrass pasture. It's an experiment that was done down in Tennessee, I believe. And if you look on the left, the pH was, there was no lime, the pH was limiting. And on the right, we have the same grass, but at an adequate pH. And you can really notice the difference. They put a ton of lime down to the acre, and you get a more vigorous growth out of the pasture grasses on the right. And this really is a take home as to why it's important to make sure your pH is in the level that it should be. We can get into, I won't get into it here, into aluminum toxicity. We get poor root growth. And if you notice on the left, the grass hasn't grown into each other, hasn't grown together. So what do you think can come in that space in between? Well, the answer would be weeds. So this is some of the reason why you start to get a flush of weeds in your pasture. A lot of the weeds are more suited maybe to lower pH. They have the space. They're not being outcompeted by the forage grass. So one of the take homes should be make sure that your pH is where it should be in your pasture. And this is actually for an experiment that I used to do when I used to teach in a graduate class. This is from years ago. If you look at the roots on the left where the pH is 6.5, and look at the roots on the right. Okay, so if you can see, you don't get a lot of root hairs. The depth isn't there. So there's not a lot of reserves. Now I'm putting horses on top, okay, that are actually tearing apart the forage. I don't have a lot of roots which I can get my carbohydrate reserves out of to help with the vigorous top growth. So that's some of the reason why our pasture grasses don't do that well at a lower pH. That's all I really had. I just wanted to turn it over. I guess I'll turn it over to Steve. But this is some of the foundation why you want to be doing that testing that we have. I guess I'll turn it over to you, Steve.
Okay, good deal. Well, Bill talked a lot about the nutritional requirements of grasses, and as a crop physiologist, I like to think of grasses as carbohydrate reserves. And Carrie mentioned about how important carbohydrates were for the horse, but they're also really important for the grass and for the grass species that are growing in your pastures. So we like to think of them all as a system working together. And the manure generated on your farm can certainly be considered a part of that system, and really does provide a lot of the nutrients that we might need to maximize our growth and development of our pasture species. So today, real quickly, we're going to talk about the potential manure management concerns for small farms. We particularly focus on small farms an awful lot in New Jersey because we're focusing on animal concentrations that are generally higher. Composting as a potential manure management solution. We talked about this in the last series of webinars, but I'm just going to touch briefly on some of the benefits from composting, particularly in relationship to using these nutrients as a nutrient source for our pasture grasses. And we're going to talk about how the bedding materials, and we touched on this as well last time, but the materials that we choose to use in our bedding really play an important role in the availability of nutrients and, frankly, the volume of manure that we're going to be dealing with. So as we talked about previously, a lot of times we don't really think about the manure management. We're really focusing our efforts on our livestock operations, but the manure nutrients that are being produced on farm really need to be considered. But we don't only consider them a waste product, we also consider them a valuable soil amendment when we're looking, especially if we're involved in crop production as part of our operations. Now, I wish it was this simple. We can't just go dump our nutrients out in our crops and be done. We do have to utilize some type of a plan to account for the nutrients that are available in this manure. It's particularly important if we're looking at using some of the woody bedding materials as well. Just real briefly, I just wanted you to see, it doesn't matter what animal species or what livestock species you're incorporating into your farm, they provide an awful lot of nutrients. And you could see here we're talking mainly about the equine industry tonight. As you can see, when we look at a ton of manure, we produce a valuable amount of nutrients that can either be considered an amendment or can be considered a pollutant, depending on how we manage it. Now, using manure as a fertilizer, when used properly, manure can provide just about all or most of the nutrients needed for most of our pasture species, and a lot of our general field crop production can meet the nutrient needs through the application of manure. Obviously, this could become a very cost-effective way of providing these nutrients. We do look at conserving natural resources, whether we're talking about improving soil quality, recycling the nutrients on our farm to minimize any of our additional inputs. And in a lot of ways, we can minimize potential water quality issues by effectively using our manures as a fertilizer for our field crops. When we don't use them properly, we all know that the potential hazards that may come, everything from algal blooms to eutrophication, to the real big one that we're really concerned about a lot is groundwater contamination. We certainly have to think about the odor and potential for insects and rodents that might come from improper using our manure. But as an agronomist and a farmer, I think an awful lot about the wasted money. If we have this resource available to us, we might as well use it for our crops. And it does provide cost savings in the form of limited fertilizer that we may have to apply. So not only is it important for our environmental management and for our water quality, it's also a very valuable source of nutrients in the fiscal sense of the word. Now, Mike touched on this during his presentation in the last seminar, but we incorporate these best management practices to maximize the benefits obtained from using our manure and certainly minimizing the potential impacts. And these best management practices, loosely defined, are a management practice designed to protect the environment while maintaining or improving our crop productivity or our profitability. So these best management practices are really important. The best way that I like to think about the use of these best management practices and using our manure on farm for our crop production is in the nutrient cycle. So as you can imagine, in the very top, we have our, in this case, equine, generating outputs in the form of either, in some cases, if you're in a meat operation, you could be producing a product, or we could be producing manure generated on farm through the excrement from and coming out of our horses in this situation. Now, not only is it the grass that the animal is eating on the pasture, but it's all the additional inputs that we put into the animal, whether it's additional feeds, supplements, additional fertilizers that we put into our operation, or in our case, when we're talking about manure management, utilizing the nutrients in our manures. So this nutrient cycle, we're trying to maximize our outputs while minimizing the inputs that are going in. And manure can become a really valuable part of this process. I like this slide, especially when we're talking about manure management on an equine farm. We certainly do not live in a perfect world. And so we do have several things that we have to consider, including our small land base. Many cases, we are really trying to maximize the number of animals in the form of animal units to maximize profitability or to maximize our output. And in many cases, the quote unquote best solution might not be cost effective. And we always, as farm operators, we're considering the business of agriculture, and we really want to make sure that we're doing the most cost effective as well as the most beneficial to the environment or to our operation as a whole. And alternative management options may be needed. And these options, especially when we're thinking about manure management, are either to reduce manure volume on farm, to minimize our environmental impacts, or to maximize these benefits that are associated with the manure as an end product. We talked about composting a little bit last session, but just to go over real quickly, the reason why we want to compost is to reduce our hauling costs in many cases. We certainly see significant reductions in mass, and we spent a little bit of time going through some of our research studies in the previous series. Increased nutrient concentrations, if we're reducing the volume and the mass of our products that are part of our compost pile, we are certainly concentrating the amount of nutrients in those piles just through through mass reduction. And by having this mass reduction, we're certainly reducing our rates that we're applying to our fields. And this becomes really important. And why is that? And if you look at this picture, this is a research study myself and Bill did several years ago. And we were looking at equine stall waste. And Mike Westendorf was involved in this project too. I apologize. We were looking at applying nutrients in the amounts that we needed for our grass production. And the field that we were looking at, this was generated a hay field. It was orchard grass. And the top left picture is traditional stall waste where we were using wood bedding as our material. And based on the nutrient concentration within that stall waste, we needed 20 tons per acre to meet the needs of our crop. And as you can see, you can clearly see this. There's some pictures in other studies where we basically almost killed the grass. We severely stunted it by limiting the photosynthetic energy that it was able to utilize in this study. On the lower right, we did the same thing, only we composted the manure, had a little higher concentration of nutrients where we only needed 6 tons per acre to meet the needs of that crop. And as you can see here, the 6 tons per acre of composted manure you can't hardly see it on the grass. And you can see the grass is certainly able to utilize the sun for photosynthesis and store lots and lots of energy while still having the same amount of nutrients available for that crop. So I think it's a really good visual to show you proper management can really increase your efficiency in your operation. Mass reduction, we alluded to it. Again, you could see by being more actively managed to the right, we significantly reduced, in this case, we went from almost 120 to just a little bit above 60 kilograms in volume or mass of our pile. And so basically almost a 50% reduction in our mass just through an active composting process. And the covering also reduces the potential for runoff from the pile and certainly protects our water resources. Now we have to think about it, and Mike had some very similar pictures in his talk last week about manure management. Is this considered composting? So it certainly is not. As you could see, there's lots of runoff that's coming off the pile that could potentially get into our waterways. So we have to make sure that we're utilizing the systems that we're trying to incorporate into our management in the best way possible. And this is certainly a picture of how not to compost. As you can see, the sheen from the runoff from the manure pile is certainly carrying a lot of nutrients. Now, a finished product generally has between a pH of 5 and 8. I'm going to tell you honestly, I have yet to see a composted equine stall waste with a pH of less than 7.5 to 8. It certainly generally is a higher pH product. And you can see from on the bottom, we have available nutrients that are some are readily available, and some take a little bit of further processing by microbes to make the nutrients available for compost or for nutrients for our pasture rather. And that makes a nice slow release fertilizer with availability to our plant, our crops over time. And as we build consecutive years of applying this composted material or any manure material, we get what we call residual nitrogen credits. So over time, we get more and more available nitrogen for the crop development and growth. Now this manure, after we decide how we're going to dispose, there's two main ways that we dispose of our manure. One, it certainly is a preferential way when we're thinking about agricultural crop production, is to spread it on agricultural land. And the second is to transport this material off-site. And we all know there's costs associated with manure transportation. Moving it off the site requires shipping fees and handling fees and such. So an ideal way to get rid of our manure or dispose of our manure is on farm in our agricultural production. So spreading on agricultural land, there's some tips that we use. Manure should be spread when the crop grown needs nutrients, or as Bill alluded to during his presentation, when the crop will need it in future dates. Bill talked about the soil test. It's very, very important that you incorporate soil testing. Bill mentioned every 3 years into our crop production. This becomes really, really important when we're looking at manure management or incorporating manure into our crop production systems. Do not spread near waterways. Mike talked about this when he talked about the rule last time, but we generally want to incorporate either buffer strips or leave certain areas away where we reduce the potential for the waste to be transported into our waterways. So I just wanted to real quickly wrap up with a real world example. Now this is a 10-acre farm. It's an equine operation. We have only 5 acres available for pasture, so we have a pretty heavy stocking density. So hopefully this farm has incorporated a lot of the stocking management strategies that Carrie alluded to in her presentation, or explained very thoroughly, I should say, in her presentation. These animals are pastured for 12 hours a day, and 20 pounds of wood shavings are added to each stall every day during the clean out. And the manure from these stalls are cleaned and stacked in a pile to be utilized on farm. So we're not going to go through each individual step in our calculation, but we assumed a 1,000-pound horse produced 45 pounds of manure per day. So if we had the number of horses, we ended up with 4.1 tons of manure per horse per year. And when we calculate that across our 5 horses, we end up with 20.5 tons of manure per year. Now we have to include the wood shavings that we incorporated, and we come up with 30 tons total waste per year generated on this small livestock operation or small equine operation. So you can see we're talking about some real numbers when we're talking about our waste that we need to get rid of on our farm. So the next step that we would do if we're going to incorporate this manure into our agricultural operation, or in this case through our pasture application, we certainly want to use the soil test results to determine our crop needs. Now, from the soil test that we took for this imaginary farm, we needed 50 pounds of nitrogen per acre annually, 15 pounds of phosphorus per acre, and 50 pounds of potassium per acre. This was by the soil test report, as Bill discussed in his presentation. Now, we looked through our typical horse analysis. If you remember that picture I showed you in the very beginning of the manure generation by livestock species and the amount of nutrients that were available in that manure. We have a 12, 5, 9 analysis, and as Bill discussed, it's the nitrogen, phosphorus, and potassium in the nutrients in the manure itself. Now, due to some chemical reactions, and I alluded to the fact of having residual nitrogen available as time goes by in successive years, we calculate about 20% of the nitrogen is available immediately in year 1. So this turns out to be a 259 analysis that's immediately available for our pasture species to utilize. And once again, we just simply go through the math and we figure that based on our application rates, if we had 30 tons generated, we have 5 acres to spread, we need to put out approximately 6 tons per acre on these fields. And you can see for yourself the nutrients that are available. We would have 12 pounds of nitrogen, 30 pounds per acre of phosphorus, and 54 pounds per acre of available potassium. And we simply, I like to think of it as a checkbook. We compare what we put out, and then we figure out what we need. So we would determine what additional fertilizer was needed. In this case, as you can see, we would certainly need additional nitrogen to maximize the growth and development of our grass. And we always want to, when we're utilizing our manure, and Mike talked about this when he discussed developing plans for your farm, or I'm sorry, it wasn't Mike, but somebody discussed last class about incorporating this information into a manure management plan. And we certainly want to pay attention to any potential environmental concerns associated with utilizing this manure on our farm. So in conclusion, manure management is a crucial component of any livestock operation. This is particularly important for small scale operations where maybe we have higher animal densities, maybe less available land for spreading. And utilizing these BMPs, you can certainly use manure as a resource for crop production while minimizing the chance for any environmental impacts. I'm a big fan of composting, as I'm sure you could tell. I think composting is a very beneficial way to reduce the mass and maximize the availability of nutrients, but it certainly does take management. And always remember, in some cases, just when there's higher stocking densities or limited land available for spreading, manure removal will be the best option for manure management. It's really inevitable in certain situations. And that's really all I have. Sorry, I rushed through it just a little bit, but we can open it up to questions, Hank, if.
Steve, this is Mike. That actually Sandy Howland who talked about animal waste management plan.
Thank you, Mike.
Steve, I did have a question. The study where you looked at different levels of manure, horse manure on pasture, you took the pictures. Did you ever make any kind of publication or take pictures of what it looks like with 2 ton, with 5 ton, with 10 ton, with 20 ton, with 40 ton? I know other states have done that and used it as kind of a guide for spreading.
We do have the pictures available. This was incorporated into another project that we worked on, and it was just a subsequent part of a different journal article. So we really don't have anything that focused just on this, but I do have a presentation where I have all the pictures kind of in a square going around, and we also compared it to using traditional inorganic fertilizer as well. So yeah, I can certainly make it available.
Sure. Yeah.
It doesn't look like we have any questions in the chat. All right. Well, thank you for coming. Thanks for presenting, guys.